Welcome to this special edition of the New Stack Makers on the Road. We're here at the Open Source Summit in Dublin, Ireland. Discussions from the show floor with technologists giving you their expertise and insights to help you with your everyday work. Amazon Web Services is the world's most comprehensive and broadly adopted cloud platform, offering over 175 fully featured services from data centers globally. Millions of customers trust AWS to power their infrastructure, become more agile, and lower costs.
Hey everyone, I'm here today with Paul Vixie, Vice President and Distinguished Engineer at Amazon Web Services. We're live from Dublin, Ireland at the Open Source Summit. Paul, thank you for joining us in today's discussion about your life and your career and how it relates to where we are with security. I'm very interested in our discussion.
Well, thank you for inviting me.
You bet, you bet. So you worked at Digital Equipment Corporation in the late 80s and early 90s. In 1994, you founded the Internet Software Consortium. And for those who don't know about it, that supports the infrastructure of the universal self-organizing internet by developing and maintaining core production quality software, product protocols, and operations. So you developed, at the ISC, there were several core internet technologies that were developed, including Bind, ISC, DHCP, and Kia. So I'm curious about the transition from DEC to the Internet Software Consortium. In particular, how did that happen? And what were you talking about with people at the time? What were some of the conversations that you were having?
Well, I think it's obvious now when you look at what happened with digital equipment. In the next 5 years, they were sold to Compaq, a shadow of their former selves. They were simply moving too slow for me. And I could see that the internet was going to be a really big thing. And I knew the only way I could really get involved in making a difference in how the internet evolved would be to leave DEC. It was hard to do. When I, got back into the real world, there was this DNS thing. This domain name system had come into vogue, and it was a big deal, and it was responsible for a lot of the internet's scale, but it was not mature.
So a question about DEC. Why did you join DEC? Had you come out of school? And what were your hopes and aspirations that you saw change while there?
Well, okay, so the story begins in 1980 when I dropped out of high school. I apparently spent too much time playing with computers, not enough time doing my homework, so the writing was on the wall. And after 8 years of sort of working in the field as, a late teenager, early 20-something, I was ready for a challenge. I was ready for something that would be a teaching experience, a learning experience for me. And DEC was the company. They were responsible for almost all early ARPANET nodes and almost all early Unix servers. DEC was the first company to do any of that, but it was really their customers, not the company. The company was not so much aware of the internet or of Unix. But when I had a chance to join, I jumped at it.
So you began to understand the internet, I expect, during that time through the work you're doing there, but also just through your own research. So then you joined the internet. So you started the Internet Software Consortium. Why did you start it? What was really the genesis of that?
I'd like to say there was a vision statement and that we got a lot of buy-in and it was sort of well organized, but no, it was quite organic. While working at DEC, Digital Equipment, I was responsible for their corporate internet gateway, which was a big deal even in around 1990. And the software that I was using was not good, and the protocols that we were speaking were not good. And I had gotten involved in maintaining that and contributing to that. So when I left DEC and started the Internet Software Consortium, it was to continue that work, specifically on the domain name system and the bind implementation of the domain name system. So ultimately, I think I started Internet Software Consortium so that there could be someone other than me to own the copyright. But then it snowballed and the internet got big, and so we hired a lot of people and did a lot of things.
That time was very special now when you look back at it, right? But even at the time, you're quoted in Wikipedia as saying, and yet it's a lot harder to break 500 duct tape systems of mixed and varied heritage than to break one well-designed system. Monoculture is intrinsically brittle, no matter how strong the genes themselves may be. That to me is really interesting because I'm curious now how you view those systems of yesterday and how they've really spread so rapidly, and what do you look back on now to think, wow, what does this reflect upon what I learned, and what does this reflect upon today and where we are headed?
Well, I think that quote in my Wikipedia page shows its age in two ways. The first it was before scale, right? At that time, there were only technical people and technical companies connected to the internet, and it was likely that every one of them was kind of a science fair project, duct taped together, trying to somehow get to a place that we could not see, inch by inch. But what is true for 500 systems is not true for 500,000 systems. And so, if you want to break into somebody's enterprise and steal their data or do ransomware attacks, whatever, you need to know about their weaknesses. And the chances of them having weaknesses are much greater in a 500,000 enterprise population than they were in a 500. And so that's why the monoculture that I was trying to avoid turned out to be both inevitable and not as bad as I thought, because at scale, you have to manage this stuff. You can't just have everything be duct tapes and Band-Aids.
What's an example of the monoculture that has evolved and emerged?
Well, certainly it's much harder to change the Internet Protocol Suite now than it was then. So there was a time when, let's say, if TCP/IP itself had a problem, like there was a lot of congestion control work that had to be done once things got to scale, you could actually change it. You could say, all right, let's everybody speak a new protocol, and we'll all switch to that protocol, next Wednesday. You can't do that now. The Internet protocols are cast in stone at this point. They're embedded everywhere. And so there's a very long tail of systems that will continue to operate no matter what changes we introduce. And that changes how we can think about the things we'd like to do differently. So I would mention that the IETF, Internet Engineering Task Force, is very busy trying to make everything more secure. But we all know that it's going to be 1 or 2 decades before the work that we're doing now has a broad impact on sort of digital society.
So what is that work that you are doing now that will have an impact in 10 to 20 years, just as much the work you did in the early 90s has had an impact on today, for in particular DNS?
So I personally have not introduced any new technology, either in my last startup or so far in my first 6 months at AWS Security. But the last things that I worked on had to do with privacy-preserving data collection that would be compatible with student privacy regulations, national privacy law, and so forth, that would collect enough information about the way the internet was being used that we could begin to home in on the people who were abusing it. That led to a lot of important advances in my previous company. And I think the DNS field is now has adopted almost everything that we did. And I think that's cool.
So what were those things that you did that have been adopted?
Well, one thing we did was called DNS TAP, TAP, and it was just a tiny piece of middleware that you would attach to your name server software so that you could monitor the transaction flow. Sort of, this is the question I received, this is the answer I gave, this is why. And that became a sort of a standard middleware protocol by which a whole analytics industry has sprung up so that people can use their DNS transaction flow to help them detect that maybe one of their employees has been compromised, or that there's malware running loose or something like that. That was never going to happen if the only way we could tell what the DNS server was doing was by looking at, packets on the wire. So DNS tap would be my favorite example. We also introduced the first DNS firewall, at least the first standardized one, so that if you wanted your DNS server for your enterprise or university, whatever, to answer untruthfully about unsafe things. In other words, somebody asks for, let's say, tell me the address that goes with a certain name, and you know that name is only going to be used by malware. You might prefer to just not answer that question for your customer, for your internal system, just as a matter of security policy. So we introduced a way to make DNS service part of your security apparatus, to deliver security through DNS service, and we made it kind of a lingua franca so that there could be a vibrant community of producers of this type of DNS threat intelligence and consumers, where it wouldn't matter what server you were running, you still had a choice of any of the vendors who were selling into that space. And that was called the RPZ. It's stupid. We should never let programmers name things, but that is also now a de facto standard across all open source name servers, and that came from us.
You sold you sold your company that you started, this company Farsight, and it's basically about a lot of the work that you did at the ISC. How was it to go from that very standards-oriented work that you were doing to developing a company with Farsight, and what were kind of like your goals and intentions in doing that? And what did you see resulting from that after you sold it?
Well, I think whenever you take some intellectual property out of a nonprofit and commercialize it, there is fear in the community that you've somehow stolen this and that you're inappropriately monetizing something that the community helped you develop. That was not true. When I moved to Farsight, when I started Farsight, and pulled some intellectual property out of my previous company, which by now was the Internet Systems Consortium, it was because we were stuck. We were delivering delivering security through DNS as well as we could as a nonprofit, and we were going to need funding and growth and a large customer base if we were going to solve the real problem. And to our credit, we paid for the intellectual property that we received, and that helped ISC produce more versions of Bind and so forth. So everybody won from that deal.
And so why join AWS then? And what are some of those challenges you're seeing that open source plays a role in helping resolve?
After I sold Farsight Security to Domain Tools, November of 2021, I took a few months off, and I was speaking to the AWS security team, and they said, why don't you come here? And I said, but I've got this mission. I've got to restore human safety to pre-internet levels, so I don't know what I'm doing next, but it has to be that. And, what they looked at that and they asked me what is now, in retrospect, an obvious question. Gee, AWS hosts probably the largest share of the digital economy that you're trying to protect. Don't you think you can complete your mission by working to help secure AWS? The answer is yes. In fact, I feel like I'm going to get more traction now that I'm able to focus on strategy and technology and not also operate a company on the side. And so it was a very good win for me, and I hope for them.
Great. And so on your mind, you must be thinking about, for example, projects that you've played a huge role in, DNS, for example. How are you thinking about how AWS approaches internet security, and what do you think is the role that the organization should play in influencing the work that we all do every day, because we all live in this at-scale world now, and we're so dependent upon it. And that AWS plays such a big role in it. I'm curious on how you're thinking of approaching these types of really big challenges and issues.
Well, part of the attraction to the challenge of working for AWS security is that it's the biggest game in town. It's a big thing. So for a more median-sized company, your biggest threat is probably coming from the outside, other people's networks, other people's unpatched servers, other people's sort of ancient technology that should not still be connected to anything. But when you are one of the big dogs, then the biggest thing you've got to worry about is how well organized are you? What's happening with your systems? And AWS has been around long enough and it's gotten large enough that we have built a lot of things that would, in a more medium-sized company, they would be bought. And that gives us a huge advantage about how we get to think about both detection and response to security events, right? Everybody is under attack all the time. We know that. There's really nothing that can be done to change that. What you have to change is how often your systems will be affected by those attacks. And so I think the way AWS is thinking about internet security is, we are the internet in some ways. We need to make sure that we have a very clean house. And, we make a lot of investments to make sure that what we do is well understood and well curated and well managed.
So you talk about organization, you're talking about things being well curated, you're talking about the AWS as the internet. What are those organizational matters that you want to address in particular?
So since I came recently, and since I was fairly well known before I came, I have a big advantage, is that people all over the company hear that I'm working here, and they want to talk to me about their worries, their unique peeves, their concerns, especially as it relates to open source software, where I was well known, and the internet protocols and the domain name system. And so I'm getting to hear firsthand what a lot of people are thinking around the company that may not have otherwise filtered its way into the executive ranks. So I don't have a grand solution, but I do know there are some voices that I can help amplify. A lot of what you do when you're a new employee, especially at the executive level, is listen and let the company solve the problems it already knew how to solve but didn't know how to talk to itself about.
So what are the themes that you're hearing from people? One of the themes that we hear a lot about, and just generally, is about the software supply chain and the concern about API endpoints and their security. Are those themes you're hearing about? If so, are there any particular issues that relate to those that are relevant to our discussion?
With the software supply chain, at least, we note two sort of extant problems in the community. The first is, programmers want to be efficient, and they don't want to reinvent something that's working pretty well the way it is, or working well enough. It affects your time to market, it affects your maintainability and so forth. And so we tend to say, all right, I gotta deliver a service and it needs a certain thing. Let's look around and see if there is a thing like that. Oh, there is. I'm going to import that. I'm going to add that as a dependency. Now, the problem is it will have dependencies of its own. And so when you're working with the software supply chain, you have to be very careful about knowing who you're depending on, and ideally who they're depending on, so that if some vulnerability or bug is announced somewhere, you can make sure that you patch it, and also that your upstream supply chain patches it. We saw in around the December, January timeframe a very famous event now, the Log4j problem. And the problem with Log4j is it had features that people didn't know were in there, which turned out to mix badly with data handling in its own call chain. But the bigger problem was most people weren't using it. Most people were using some package that had a dependency on Log4j. And so you didn't necessarily know whether you were affected. And we're going to have to change that. So just what I mentioned earlier, curation is very important. Just sort of an understanding of what you're publishing and what you're depending on. And then if what you're depending on changes, you have to work very quickly to get a patch into your system. And that's actually one of the advantages of scale. A small company with a small development staff who understands their business workflow very well is maybe not staffed well enough to do this in addition to everything else. And I think that's one of the big advantages of the cloud, is that you can depend on your cloud partner, your cloud operator, to sort of say, look, we're going to be responsible for this part, you're going to be responsible for that part, and let's talk from time to time. Ultimately, security begins at home. Every team has to spend a certain amount of effort thinking about how to secure their stuff. And I guess one of the points I'd like to amplify is that security sounds important. It sounds like it involves big locks on doors, new crypto algorithms, large keys, guns and so forth. And that, I'm sure, is involved. But if you have a great lock on your door, but you don't manage the key carefully, then it won't matter how good the lock was. And so a lot of success in security just has to do with discipline. And again, at scale, you can apply discipline over a larger defense surface.
I think about the movies and like how always there's like this, like the hero is able to get through the fortified, arm guards and the walls and the guns and the hero always has like these karate skills or martial arts skills or can throw knives and eventually gets through, right? To save the day, right? You can almost think of that as like hackers, right? They're like, they're getting through all these kind of ways. And so I was actually reading an article on this topic where, the whole idea here is that actually software security, has a premise that the more open it is, the better, right? In some ways, right? It's much better to have, in many respects, open cryptography than not. Because if you have closed cryptography, only a few people are going to be able to really kind of determine how it is. And so how do you want to, is that something that you agree with? Is it something that you think is important? And how do you think that affects kind of like, customers at AWS and how they view the software supply chain and how AWS views it itself?
The answer has changed over time. So in the 90s, I remember sharing a stage with Mad Dog, John Hall, where one of the points that we discussed on a panel was the fact that proprietary software might have bugs that are only going to get studied by the people trying to attack them because they're willing to sort of disassemble it and carefully look through everything. Whereas open software gets looked at by everybody, and so if you have more eyeballs looking at something, then you're probably going to find more things sooner. And so there's a possibility that open source will have a structural advantage over proprietary software just because it is inspectable and is therefore widely inspected. And I think that was our position going into the great expansion of the internet and open source. But it's not always true now. So if you think about the shell shock announcement from, I guess, almost 10 years ago now, it turned out that the almost universal shell used on Linux-derived systems, including all of the little embedded ones called Bash, had a problem where, again, it's a little bit like Log4j. It had a feature that nobody knew about, and that feature mixed badly with the management of the data that you handed in. What fascinated me about that is that it was committed 2 years earlier. There was a commit that added the feature. There was exactly the right code review according to all the rules, and it was there for anybody to inspect,
Right.
but it took 2 years. All right, so what that means is the structural advantage is not as obvious as it used to be. Open source software being more inspectable only helps you if you have enough people to look at it all. And there is so much open source software now that I don't think we could possibly have enough people to look at it all.
Yeah.
And so, if you bring this back to how AWS treats open source software, before we ship our own software, it goes through this application security group who sort of squeezes it hard in every direction and tries to make it misbehave so that we're not in the position of publishing something that has a vulnerability that we could have discovered. Now, there's no guarantee that you'll do that, but we try pretty hard. We have also got teams who will look at our dependencies and maintain relationships, where possible, with the people we're dependent on. And of course, we work with the CERT organizations around the world, CERTs, so that when there is a vulnerability being reported, we will hear about it and we'll have a chance to manage it. What this comes back to is open source software can be safer, but you have to do a lot of work, right? So I guess the other thing I'd like to amplify is that when you get something for free, it probably means that you're going to have to do something. And in this case, what you have to do is make sure that you hear about patches, subscribe to whatever the GitHub repository, whatever, so that when things go wrong with the things you've decided to import, you become aware and you're able to take action. That action may involve working over a weekend, but again, if you're getting something for free, chances are you're going to have to do something to get it. That's what you have to do with open source software.
And that's really a good lesson for your customers, isn't it? With open source software supply chain.
We would like all of our customers to pay close attention to what they depend on, make sure that they have the resources to respond quickly, and also make sure that if they themselves have a problem and they are producing software that other people are using, that they can, again, act quickly, publish the patch, publish the vulnerability disclosure, and help the world stay a little bit safer than we would be if we had 500,000 unpatched enterprises out there, each running their own duct-taped version of software. A private fork, for example, where somebody makes a copy of some software and modifies it, you got to make sure that if the thing you started with gets a bug report on it, that you go look and see if it affects your private fork. That's like work that you have to sign up for in order that open source software do you more good than harm.
Well, thank you so much, Paul, for your time today. It's been real interesting to hear your story and how you view internet security today and how that story has been built over many years of hard and distinguished work. So thank you for your time.
This has been great. Thanks for sitting with me.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.